Hello, statisticians. I had a couple students asking about the 4.2 homework, specifically questions like number 11 here, which I'm going to do. Uh, so I'm going to go through this problem. I just copied and pasted the question over here so I can write on some stuff. So this is a question about a proportion. The null hypothesis is that the population is 0.7%, and we're comparing that with an alternative hypothesis of that the population proportion is less than 0.7%. So it doesn't give you any real life context, but just to give this a meaning, let's say that you think that you're wondering about how many people are staying home uh, because they are their job is non-essential for coronavirus reasons. So you think that 30% of people are still going to work and 70% of people are maybe staying home, and that they're either unemployed or they're working from home. And you get a sample that says that only 62.5% of people are staying home and not going to work. So it's more people than you thought are going to work with fewer people than you thought staying home. And what you're wondering is how, and this is out of a sample of 200 people, how strong is this evidence from this sample that you get, evidence that fewer than 70% of people are staying home, either because they're working from home or because they're suddenly unemployed or whatever. So what we want, the question is asking you to find the p-value for this hypothesis test. So what that means is, assuming that the null hypothesis is true, that the population proportion really is 0.7, what is the probability that we would get a random sample of size 200 with the sample proportion p hat as low as the one we actually got? So that's what we're going to find using Statkey over here. So here is the Statkey website. We're going to do a randomization hypothesis test for a single proportion, because that's the kind of statistics we're looking at. So I'm going to edit the data to, the data is based on the sample that we got. And the sample that we got was 125, said yes out of 200. That's that 62.5% from the sample. The null hypothesis is that the proportion, so I clicked on null hypothesis, that the actual population proportion is 0.7. Okay, so when you generate a randomization sample, this is generating randomized, like assuming that you're from a population that's 70% saying yes. So I get one sample. Oh, I got 136 out of 200. It's like 0.68. Okay. So that's one kind of sample we've got. We want to see how spread out are these samples. How likely is it that we would get something as low as 0.625? So I'm going to generate some more samples. These are some more randomized samples from a 70% population. And so far we have none of them are actually as low as that, but we've only done 8 samples. So we get more samples, and if you just get like 100 samples, you might get a decent idea. But with just 100 samples, there's some like random chance, like exactly how many are going to be down here. So right now it looks like there's 2 out of 120 that are below 0.625. Or maybe this one's exactly 0.625. Okay, so there's 3 that are that far down or lower. So it's still a little bit random. So I'm going to generate some more samples until we get a pretty good idea. So at this point, 0.0625 is in here. So we're going to do a left tail hypothesis test. So I'm going to click on left tail, and then I'm going to click in the number for what we actually got from our sample, which is 0.625. That's the cutoff we want. And we can see that there is 0.012 is the proportion of the data that is this far or farther below. I just realized that the 0.625 is cut off from the frame here. This moving my frame around a little bit. There we go. So this is where we enter the cutoff. So that's where I clicked on that thing there, and that's going to be 0.625, because we want to know what is the proportion of random samples from this 70% population that would actually be this low. And that came out to be about 0.012. Now, something about this is sometimes it could still be a little bit randomized. You can see this isn't like a perfectly smooth curve yet. So to take care of randomization problems, to make sure that your proportion is really like the true proportion that you should get, I'm going to generate a few thousand more samples. And you can keep going until you do like 10 or 20,000 samples, and you'll be pretty accurate, just to be sure. Okay, so there's like 12,000 something samples. Now you can see that we have a really smooth curve. I'm going to click this again just to let it recalculate it at 0.625. Okay. And yeah, it is the 0.012 was accurate. So that is the p-value. That is the probability that in a population where the proportion really is 70%, you'll get about 1.2% of samples this low or lower. So I'd say this is pretty strong evidence that the true population proportion is not really 0.625. This is something that's fairly unlikely to happen, very unlikely to happen, if the population was really 70%. So we got the p-value is 0.012, which you could also write as 1.2%. And depending on what your significance level that you need is, you would probably reject the null hypothesis and say, yeah, the true proportion is probably something less than 0.7, probably something closer to 0.625. And so I'm going to try entering that in here just to make sure that it works with the homework. 0.012. Incorrect. Okay, so maybe this is what was happening with people and why people are asking for help. So it might be that this question has a bug, or it might be that I need to generate some more samples to try this again. I'm going to go up until we get to like 20,000. Okay, I think I'm overwhelming Statkey. Need to wait a minute for it to respond. Okay, so I'm going to click this again just to make sure it's recalculating it. The cutoff is 0.625. Okay, now it's 0.013. Okay, so I'm going to go back here to 0.013 and try that answer. It's still telling me I'm incorrect. Okay, so this is probably one of those situations where there's a bug in Statkey. I'm not sure. Let me see. Okay, so I just paused the recording for a moment so I could figure it out, and I realized there is a bug in the problem in WileyPlus. It's The correct answer when I go to my instructor's view here is it says the p-value should be 0.015. So if you watched all the way through this video, congratulations, you can get your 2 points here. The real answer, well, the answer I got from Statkey was 0.013 or 0.012. I know a formula for how to do this using, and I just did it using my TI-84 calculator thing here, and I got 0.01. This is a formula we're going to learn in section 6.1, I think, that lets you calculate what you would get from a hypothetical population without actually randomly generating stuff using Statkey. This is the way people used to do this before they had computers that could come up with thousands of random samples. And they just could do a few calculations. And it comes up with 0.01. So really, I would, if this was a test, I would take anything between 0.01 and 0.015 would be fine. But either WileyPlus has a bug or Statkey has a bug, or both of them have a bug, because it really should be 0.01. So this is one of those cases where online math homework has problems here and there, and it is really frustrating, I know, for people working on it. And thanks for emailing me to let me know that you were struggling with it. But what I should also say is that I'm going to give people credit for, and because of problems like this, I will be curving the homework grade somewhat, probably adding something like 5% to everybody's homework grade at the end of the semester. I'm going to look at like what are the highest scores in the classes, not like the highest one score, but usually like the highest 5 or 6 scores. There's usually at least 5 or 6 very good students who really tried hard on every single homework problem, and see what they're getting. And if they're getting something like 95% of the total points, I'm just going to add 5% to everybody's score to turn problems like this essentially into freebies. So sorry if you were banging your head against the wall with this, but you know, at least you were practicing statistics while you were doing it, and you'll probably be ready for a problem like this on the test. So it's not the worst way to spend your time, but sorry if it was frustrating, and I'll see you in office hours.